Hello and welcome to a brand new video. So today we're going to be talking about the maximum length repeat subarray problem. And in this problem, you're given two integer arrays, nums1 and num2, and you need to return the maximum length of a subarray that appears in both arrays. So for example, you can see in this example, we have 3, 2, 1 repeated here and here, but unfortunately, it's not longer. So we return 3. So how do we approach this problem? So we use a concept called dynamic programming. The link on the screen is where I got the snip from, but it is an optimization for recursion. It takes exponential to linear, and you can store the results of problems you've already solved so that you don't have to recalculate them. And this will make our lives much easier because we can use dynamic programming to find our subarrays. So let's test it out. So what we're going to want to do is instead of making the array linear, we're going to make it a matrix. We're going to make it 2D. So I'm going to say my matrix is 2D and it's just going to be lengths kind of like that. Here's the thing. What we're going to want to do is if we find that this is equal to a number inside num2, we want to take the number after that and see whether it aligns, which here's what I mean. If we have 3, 2, 1, and we have 2, 4, 2, 1. So let's say that we are going backwards. So you first take a look at this number, then this number, then this number. So we see that this is the same. So in that position on the matrix, this index will be I here, and this index will be the J, so be the second one. If it's the same, we'll make it 1. And then we'll go to the one after that. And if this is the same, we're going to take the previous number 1 and add it. So what I'm trying to say is that now the length is 2. So we took the length of the position before and now we're adding 1. So basically, in terms of the matrix, you have matrix I of j is going to be equal to 0. Then when nums1 of I is equal to nums2 of j, then we can set matrix of I of j equal to matrix of I plus 1, j plus 1, plus 1, which means that I'll take the length of the subarray here and just add 1. And this will allow us to calculate the maximum subarray length. And because of that, we need to make this plus 1 so that we don't have an error. So when you declare an array like this, all the values are automatically set to 0, so you don't need to do anything about that. Then I'm just going to create ans equals 0 for the maximum value so we can keep track as we're iterating. So do for int I equals nums1.length minus 1, I is greater than equal to 0. And remember, I'm doing it backwards, kind of like I said here, because going backwards will allow us to keep track of whether or not the subarray was already there. So minus 1, j greater than equals 0, j minus minus. So that means that if nums1 of I is equal to nums2 of j, kind of right like I talked about here, then we want to have matrix of I of j equal to matrix I plus 1, j plus 1 plus 1. So the advantage of this is that now we, like I explained earlier, are able to keep track of how the length of the subarray grows. So first it was 1 here, then as we go space back, now it's 2 because these two are the same, and so forth. And then because ans is the max, we're going to say ans become max of matrix of I of j and ans. And we're going to return ans. So overall, I'll re-summarize what we did. So first, we used dynamic programming in order to keep track of the length of the subarray we currently know about, and then just add one as we go backwards. So I'm going to delete these comments, and let's test our code against the example. So as we can see, we got 3, and in the notepad, it also says that the answer is 3. So I hope that you learned about dynamic programming and how to use it in this video, and see you next time.